What's up? Lesson 43 time. This will be a bit of a review from a couple of lessons ago. I guess 3 lessons ago. We did the lesson on rate of change. Because I expressed rate of change as kind of an application of, no, rate of change kind of covers a whole bunch of things, and one of the applications is slope. So today, lesson 44, finding slope using the slope formula. I gave that to you, but I want to kind of show you something in there that a lot of people get confused about, and just try to hope to help you plug things into the right place, but see it as a picture as well. If we can hit this from a couple of different angles, then I think maybe conceptually you'll get it a little better. So let's just do some quick review here. They say the new concept is talking about slope, right? And slope being definition as the steepness of a line. Actually, it's measuring the steepness of a line. So we're talking about when we've got an XY grid and a graph and we've got a line cutting through there. Is it kind of like going from left to right? Is it going up kind of gradually? Is it going up a whole lot? Is it going down steeply? Is it going down but just a little bit? Or we had some of those weird cases where maybe it's only going up, which, I mean, think about driving on a road like that. You don't do that in a car. Or just going flat. Well, you get that. Going flat, no slope whatsoever, just going straight down the road. So we know that. Well, I think we know this. But if you had some cool thing on your phone, or if you're playing around on a graphing calculator and you kept changing the value in an equation to increase its slope, you would see that as the number gets bigger, then your line gets taller and taller and taller, steeper and steeper and steeper. Or if you make it negative, then it'll be pointing from left to right, downward. Okay, again, we always have to remember we're always going from left to right, and I'm going to try to keep drawing the arrows instead of putting the double-headed arrow like that for now. I'm going to make it like this so that you can realize we're always shooting that arrow from left to the right side. So there you go. That's one interpretation, is looking at the steepness or measuring the steepness of a line. It is used so often in math, and in the last episode I said that there's some things that carry on even into calculus that just come up over and over and over again. This is one of them. One of the most important original ideas for how calculus was developed was finding the slope. That was a problem on things that are curved, of finding the slope at one specific place, which is something that you have to get around because you would have a change in x of 0 at that place if you're just picking one place. But we don't need to worry about that right now. Because it's used so often in math, it's given its own symbol. You know, you got x's and y's and a's and b's and things like that, but the symbol that's used to just represent slope is the letter m. And I'm not sure exactly where that comes from, but we have already defined this in a previous episode. We defined this as, well, I said it as the change in the y value compared to the change in the x value. And if you recall, on a graph, the x-axis goes horizontally and the y-axis goes vertically. Or actually, all the x values go this way, and all the y values go this way, but we're finding out those specific places when we go this way to find x, and then we'll go up to find its value in y. So we want to know how much something changed from maybe this point to this point, first of all in the x direction, and then in the y direction as well. We also talked about looking at it just from the side and seeing it's right here in the y direction, and then it's right here, and what's that change? Or looking at it from this way and just thinking about that the x is there and now the x is there, and how much that has changed as well. I defined this change in y over change in x by defining each one at a time. that it's a difference between the second y value, which I guess would be right here, and its first y value, which would be right here. So we're taking this number and we're finding out how far it was away from that number. And then on the bottom, we had to change an x be how far away the second x point is, its value, from the first x point's value. And then what is the change in the values there. So there's your definition. I'm going to take those away, and we'll give you the formula. See, these are all equivalent then. Slope is a change in y over change in x, which is the same thing as y2 minus y1 over x2 minus x1. And this is something that you better put a star by, circle it, highlight it. This is something that you need to memorize. It needs to be part of your mathematical guts. Okay? So take a moment and put that down in your notebook. You can just hit pause right now and copy it down. But this is what we're going to use. And I'll give you an example here that says it really doesn't matter which point you pick as being the first and the second, as long as you keep track of which one goes where. So here we go. Give myself a little room. I'm going to rewrite that equation up there, and then we'll work through a problem or two. Okay, I've rewritten the slope formula up here. And first what we're going to do is we're going to take 2 points, and we're going to use those 2 points to determine the slope. A point is made up of something that has an address, right? Like x1, y1, and then we're going to pick another point, and we're going to call it x2, y2. Every point has 2 parts to its address. So we'll call this point 1, and this one's the address for point 2. Okay? And I've put those up there. And I haven't told you which one is point 1 and point 2, but typically you use the one that's further to the left as your first point and the one that's further to your right as your second point. But I'm going to show you that it doesn't really matter. And the 2 points here are 2, 4, and 6, 6. And I'm a very visual mathematical person. So I usually use a little bit of graph paper and just plot those 2 points out so I can see where they are, and then my answer makes sense. My guess is that I'm going to have a positive answer for this because it looks like the slope is going up from the first point to the second point. So once I've got those points down, I just have to define them. I have to see that 2 is going to be my first x, and 4 is going to be my first y. And I got to define this point as being, there's my second x, and there's my second y. Okay? So I'm calling this one right here point 1, this one right here point 2. And I'm just going to do this mathematically now. I'm going to plug these numbers in to the slope formula. And so I just have to follow along and say y2, and then find that. That would be 6, minus, and then use y1, which was 4. Now on the bottom, I'm supposed to find x2, and that would be 6. I'm going to take away from that in the formula x1, and that would be 2. But once everything's in the right place, I can determine what the change in y is compared to the change in x. So 6 minus 4 is 2. 6 minus 2 is 4. We're going to reduce that down to 1/2. So it looks like that this graph goes up 1 every time it goes over 2. Up 1 over 2 to get from point 1 to point 2. But what if I want to get sassy and switch those points around to find them differently? What happens? Do I get the same answer? Or do I get a different answer? Because I don't want to get confused about which point is which point. That's very important. But I want to know if it matters which point goes first. So let me switch those, and we'll make that my second point and that one my first point. And we'll track these things and see if I get the same slope. So I'm going to call this one x1 and this one y1. I'm going to call this one x2 and this one y2. plug them into this thing again. So I'll get y2 is 4 minus y1 is 6, and I'll get x2 is 2 and x1 is 6. Now it looks like we're going to get some negative numbers here, but I think we're okay. You can see where this is going. 4 minus 6 is negative 2. 2 minus 6 is negative 4. Well, it's a negative divided by a negative, so that still results in a positive value. Then this fraction reduces down to 1/2, which is the exact same answer that we had when we picked the other points. What most people do if they're going to mess up is they'll just put these things in the wrong place. They will take the point 2 and 4, and they'll go 2 minus 4. And they'll take this one and just go 6 minus 6. They just don't put those positions in the right place. They don't put those point values or their address in the right place. So like if you're writing a letter and you don't put the address in the right place, it won't get to the right place. So you have to make sure that you follow the rule, which is right there. Identify x, y, and xy, the first one and the second one, whichever way you want to do that, and then plug them into the formula. You should get the right answer if you set things up the right way. That is the main thing. So sometimes they'll give you more than 1 point. They'll give you like they're doing some research or they're taking some measurements. And what if they end up with 3 points? Like maybe they get an XY grid and they're writing down all their values, things that they checked out, and they get something like this. What do you do if you're given 3 points? Well, you only need 2 points. So you can pick any 2 points. Here's where you get options. Here's where you get choices. If you'd like, you can pick, you actually have 6 different options and they'll get the same right answer every single time. This could be 0.1 and that could be 0.2 or 0.1, 0.2 or 0.1, 0.2 or 0.1 and 0.2 or 0.1 and 0.2. I've lost track, but there's 6 of them that you could pick to get that. So maybe I'm going to pick 40, negative 12 to be 0.1, and I'm going to pick 0.2 to be negative 5 and 6. That's fine, as long as I put them in the right places. As long as I go 6 minus negative 12 and negative 5 minus 40, I'll get the slope of that general trend of the data that they've gathered in here by going 6 minus negative 12 is 6 plus 12 is 18, and negative 5 minus 45 is negative 45. That can be reduced because everything's divisible by 9. We get a negative, and 18 divided by 9 is 2, and 45 divided by 9 is 4. I'm blanking here. What times 9 is 49? 5 times 9? Yeah. Any 2 points that I want to pick, I just have to pick 2 points. I don't have to use all 3 points. I only need 2. And that will be good enough to find the slope of these things. A third thing you can do is that they already give you a picture. And so like I said before, I try to draw the picture so I can see where those things are at. But they will just say, identify 2 points on a line and then use those 2 points in the formula to solve for the slope. Lastly, as a point of review, we already said that if you have a horizontal line that's going straight across, that is a y equals a constant line. It has no slope. A slope is just 0. It's not undefined. It's just 0. And if you have a line that goes straight up, it has an infinite slope, which is undefined. Okay, so that's an x equals a value. There is no slope for that one. There is no definable slope, whereby a horizontal line has a slope of 0. We discussed that a few lessons ago, so that is no new surprise. Rate of change then is that ratio that compares the change of one thing to another, also interpretable as slope. Multifaceted, lots of different applications for the same concept. Ask some questions, okay? Don't leave it up to yourself. See you later.